Hello everyone, welcome to the SQRT channel. In this video, we are going to take another problem from Indian Olympiad qualifier in mathematics from 2021. In this problem, we have a polynomial. Let's name it P. We know that P of SQRT root of 7 plus SQRT root of 5 is equal to 2 times SQRT root of 7 minus SQRT root of 5. We also know that P is the polynomial with minimum degree and it has integer coefficients. We are going to find P of 2. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem. Also, please subscribe to this channel and we will see you in 15 seconds. To be able to solve this problem, we are going to start with what we know from the original problem. It said that polynomial P should be minimum degree. So what we need to start with is basically Px is going to be ax plus b. This is going to be a polynomial of degree 1. If so, then we have the polynomial for SQRT of 7 plus radical 5 needs to be 2 times radical 7 minus radical 5. So we are going to apply that and use this value for x. The result is going to be a times radical 7 plus radical 5 plus b needs to be 2 times radical 7 minus radical 5. If you try to solve this problem, you're going to end up with a needs to be 2 and then b needs to be minus 4 times radical 5. Obviously, b is not going to be an integer here, and remember we wanted to have a polynomial with integer coefficients. So we cannot find any linear polynomial to solve this problem. Now we are going to use a polynomial with degree 2. As a result, we are going to have ax squared plus bx plus c, and now we need to use x is equal to radical 7 plus radical 5. If we use this and then simplify the expression that we have, we are going to end up with 12 plus 2 times radical 35 times a plus radical 7 plus radical 5 times b plus c. And obviously, this needs to be 2 times radical 7 minus radical 5. As a result, we need to find the value that we can have for a to be able to result in what we have at the end. And if you try to do this, you can see that we cannot find any integer coefficient to use this. So degree 2 is not an answer here. Now we need to use a polynomial of degree 3. Let's start with ax cubed plus bx squared plus cx plus d. And then we will use radical 7 plus radical 5 for x. If we do this and then simplify it, we are going to end up with an expression that you are seeing here. We have d, we have radical 7 plus radical 5 times c, we have 12 plus 2 times radical 35 times b, and then we have the expression that you are seeing here times a. Let's see if we can find values for a, b, c, and d to satisfy the equation that we are seeing here. First of all, we need to make sure that we are not going to end up with anything like radical 35 at the end. Because of that, I'm going to put b to 0. As a result, what we are going to end up with is an expression that we have multiplied by SQRT root of 7, an expression that multiplies by SQRT root of 5, and D. As you can see, the outcome doesn't have anything except for radical 7 and radical 5. So we need to put D is equal to 0, 2. If we do this, then we need to have 2 for the coefficient that we multiply by square root of 7. So 7a plus 15a plus c needs to be 2, and then 5a plus 21a plus c needs to be negative 2. If you try to solve these two equations that we have, which only have a and c, we will end up with a is equal to negative 1 and c equal to 24. As a result, we can find a polynomial like negative x to the power of 3 plus 24x that can satisfy the original problem that we had. And this is the minimum degree polynomial. And that's our final solution. Thanks for watching the video. If you would like to see more puzzles, math involved activities, and problems from different math competitions and Olympiads, please kindly subscribe to this channel. This is the SQRT channel. See you in the next video.